Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Integrate the following with respect to x. We have 1 by 6 minus 4x, right? So what have we been given? We've been given dy by dx and we've been asked to find y, right? So that's the meaning behind integration, right? So we've been given dy by dx. Let's write that down. And we've been asked to find y. And how do I represent my y? I represent my y using the integral symbol, and I've been asked to find integral of 1 by 6 minus 4x times dx, right? And we will have to reduce y to an expression which is much simpler than what we are seeing right now on our screen. So we will do that by the method of substitution. So what is that substitution that will simplify y? 6 minus 4x equals t, right? Which means when I differentiate on either side, I get minus 4 times dx equals dt, right? Which means my dx equals minus dt by 4, right? Now I have dx in terms of dt, I have x in terms of t. I go back to my y and then I write my y in terms of t and see whether it is being simplified, right? So I have 1 by 6 minus 4x is nothing but 1 by t, and then dx is nothing but minus dt by 4. So I pull out my minus 1 by 4, and then I have my expression integral of dt by t. Right now, is this expression very familiar to me? The answer is yes. The reason being, I know that my d by dx of log x, right? And when I say log here, what I'm referring to is the natural logarithm, which means it is to the base e, right? D by dx of ln of x is nothing but 1 by x, right? And which also means, because one function can have multiple antiderivatives in the world of integral calculus, right? So I add the arbitrary constant because my d by dx of an arbitrary constant is 0, and therefore when my d by dx of ln x equals 1 by x, my d by dx of ln x plus any constant is also equal to 1 by x, right? Now I try and relate this to what I have in my y expression, right? So I have minus 1 by 4 dt by t, and when I write that, I get ln of t, right? And this is where you will have to understand this very closely. While I have my d by dx of ln x plus c equal to 1 by x, right? When I put back the antiderivative for the function 1 by t, I will have to represent it as ln of mod t, right? And why is that? Because my t cannot take negative inputs, right? Because ln of a negative number is undefined. So we rewrite the antiderivative as ln of mod t. Let me write it here itself so that it becomes a lot more clearer. So what happens is dx by x, right? By x is equal to ln of mod of x c. So when you watch out this, you notice that whenever x takes a positive number, your mod x equal to x, right? And whenever x takes a negative number, what happens to your mod x? Your mod x takes a value minus x, right? And when you differentiate ln of mod x plus c, what happens is that be it a negative or a positive number, you will get back your dx by x. Why is that? Because ln of mod x, whenever x is negative, is ln of minus x, right? And then when you differentiate ln of minus x, what do you get? You get 1 by minus x into d by dx of minus x, which is again a minus 1. So your minus and minus will get cancelled out, and therefore the best way to represent integral of dx by x is ln with a mod of x and not ln of x, right? And therefore we have ln of mod t, right, plus c. and then I'll have to put back my final answer in terms of x, and what is my t here in terms of x is nothing but 6 minus 4x, right? So I replace my t which 6 minus 4x, and there I have my final answer. Everything is in terms of x along with my arbitrary constant. So let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.